All right, the next lesson, 11-2, we're solving systems of equations again, but this time we're going to use substitution. So this is a more algebra-heavy method than the graphing. The reason we would need multiple ways to solve is that in graphing, it's not always convenient to graph, especially, if the y-intercept was like -1,000 or something, that's not an easy one to graph. And also, they don't always end up to be exact integers, so if we're doing fractions and stuff, it could be more difficult to tell on the graph for an exact answer. So there are other ways to solve systems, and one of those is substitution. So what you want to do in substitution is you want to solve one of the equations so that it either looks like y equals everything else or x equals everything else. And one isn't better than the other. They're both equally good. So just get one of the equations into that place, and then you can substitute it into the other. I'm actually going to start on problem 4 on this one. One of our equations is solved for y. We've got y equals -3x. So what I'm going to do is rewrite the other equation. And the place where there's a y, I'm going to put a set of parentheses because I'm not going to put y there. Instead, I'm going to put the thing that y equals, which is -3x. We said that y equals -3x, so I can substitute this and solve my new equation. So we still have -4x, but then we're going to multiply -2 times -3x. That will give us +6x equals 4. Here we have some like terms. -4x plus 6x, that's 2x. And finally, to solve for x, to isolate it, we're going to divide both sides by 2, and we come up with the solution that x equals 2. And while it feels like we've done a lot of work, and we are happy, and it feels like you should be done, but there's actually a little bit more to go. What we need to do now is we want to solve to find out what y equals. So we're going to take this x equals 2 and plug it into the other equation, right? So we're going to replace the x there with the 2 that we discovered it is, and we now know that y equals -3 times 2, which is -6. I'm going to list this as an ordered pair, just like we did in lesson 11-1. 2, -6. The x value is 2, y value is -6, and there's our solution. I recommend that you check to make sure that it works, so I'm going to plug it into both of these equations and see if it does. If I replace the x in this highlighted yellow equation, if I replace the x with 2, I would get -8. If I replace the y with -6, I would get +12. So now I'm asking myself, is -8 plus 12 equal to 4? And since it is, then I know I've done it correctly that far. Let's check this one as well. Y is -6. If x is 2, are these statements true? Is -6 equal to -3 times 2? And the answer is yes. So we've got the correct answer there. Okay, let's see. Let's try number 4. We have one equation already solved for y. Okay, so I'm going to take that equation and plug it in where there's a y in the other equation. So I'm going to take 4x minus, big set of parentheses, and inside the parentheses I'll put -2x plus 7. We're going to distribute this negative throughout the parentheses. So 4x plus 2x minus 7 equals 23. We could combine like terms, 6x. We could add the 7 to both sides. So we get 6x equals 30. Divide both sides by 6, and we have found that x equals 5. This is not the end. We're going to take the x equals 5 and plug it into that equation to find out what y equals. So we've got y equals -2 times 5 plus 7. -2 times 5 is -10. -10 plus 7 is -3. So we have x is 5 and y is -3. Let's check this out. Up in our equation, we have 4 times 5, that's 20, minus -3, that's 20 plus 3. There we go, it's 23. Here we have -3 equals -2 times 5, that's -10, plus 7, that's -3, so that one works as well. All right. Sometimes one of the equations isn't already solved for x or y. So take a look at number 9 with me. We don't have an equation that looks like x equals stuff or y equals stuff, and we want an equation that looks like that. We could pick any point, but if we're strategic about it, it'll save us a little bit of work. So I want to solve this top one for x because there's no coefficient in front of the x and it's positive, and so this is going to be an easy one to do. All I have to do is subtract 3y from both sides. So that equation becomes x equals 14 minus 3y. Now what I can do is take that thing that I found that x equals and substitute it into the other equation for x. So that will look like 16 times 14 minus 3y, and then we'll keep going with the rest of this equation, plus 8y equals 24. Okay, so what we have here is this equation, except where the x was, we put 14 minus 3y, since that's what x equals. Okay, let's go ahead and distribute. We'll keep the purple for a minute. 6 times 14 is 84, minus 18y plus 8y equals 24. We have some like terms, and we can subtract away the 84 to the other side. So my new equation becomes negative 10y equals negative 60. I can divide both sides by negative 10, and I find that y equals 6. That's good news, but it's not the end. Let's take this y equals 6 and plug it in up there. So we'll have 14 minus 3 times 6. Negative 3 times 6 is negative 18. And 14 minus 18 is negative 4. So we know that x equals negative 4 and that y equals 6. There's my ordered pair. We want to check our work and make sure that it holds true. And I think this is enough to get you ready for the next one. My problems 10, 11, and 12 are a little bit more difficult than any that they have on the homework. So remember that you can solve for x or y. You just want to get x equals stuff and y equals stuff. Let's talk about special situations here. Suppose that you're solving one, and it looks something like that. As you simplify the like terms over here, you'll notice that they go to 0x. So x is gone, and we're left with the equation 3 equals 10. When all the variables go away, there are two possible solutions for the whole thing. One is was no solution, or you could have infinitely many. Okay, so when you get this special circumstance of the variables sort of all disappearing or canceling each other out, to decide which it is, whether it's no solution or all solutions, you're going to look at the statement that you have left. Since this is a false statement, because 3 does not equal 10, then I know that that's a no solutions. Whereas if we'd had a problem like negative 7x plus 4 equals negative 7x plus 4, we would add 7x to both sides. X's go to 0, and we're left with 4 equal 4. Since the variables are gone, and we're left with this means that we have infinitely many solutions. Sometimes when you're solving these, at least I often get to a place where it looks like 0 equals 0. And that's where I'm like, okay, I'm done. There's nothing else I can do here. That's a situation that is a true statement. 0 does equal 0, so that would be an infinitely many solutions. Not to be confused with something like this, though. If you have 4x equals 0, you could divide both sides by 4. Notice the variable did not go away. So there we have an answer, something equals 0. Okay, so notice the difference between these. On the left, we do have a variable, so we still have a reasonable solution to find. And on the right, variable is gone, so it's either no solution or infinitely many. We just have to see if the statement is true or not. All right, good luck.